Hey everybody, we're going to do a quick intro into polynomials. This will be something that we use throughout the rest of the chapter, just some good background information for us to have. So our objectives for today are pretty simple. We got to do a couple definitions. So the first thing we're going to do is determine what is a polynomial, and we're going to define that, give some examples. And then the second objective is to define what are degrees and coefficients, just some vocabulary for us in this video. So starting with what is a polynomial. So it uses one variable. It can be anything. It can be any letter that we know. I'm going to use x for the definition, but it doesn't have to be x. But it uses one variable and can be written as the sum or difference of any terms. Now, terms are things that are separated by multiplication or division. And so the term can be any number in the front times x to any whole number exponent. And whole number, just to clarify, is anything 0, 1, 2, 3, or beyond. It's not negative numbers, though. So our variable has to have an exponent that is a 0 or positive whole number, and the coefficient or the number in the front can be anything. So for example, we can have a function f of x that equals 7x to the 5th plus 2.5x to the 3rd minus 1/2 x plus 7, and that's good as a polynomial. Now this 7 here, down at the bottom, right here, is a constant term. So that is really can be written as 7 times x to the 0, and 0 is a whole number, so because anything to the 0 power is 1. So as long as you see just this constant number, that does not violate our definition that we've given. So that is good as a polynomial. Another example that could work would be this 2 times the term x plus 2 times x plus 5. We can rewrite this in a form that looks like our definition, 2x squared plus 14x plus 20, if we went ahead and multiplied that out with a generic rectangle. So both of those are good examples of an exponent. Now we're getting a little foreboding here with our red ink. So this example down here, y equals 2 to the x power minus 3, that would not be a polynomial because our variable is now the exponent, not the base. So because of that x that's our exponent, we don't know what x is, so it could be any number that violates our definition for a polynomial. It could be a negative, it could be a decimal, anything like that. So this is not a polynomial down here. Another example of something that's not a polynomial would be this 1 over x squared minus 2x plus x. Because of these two terms that are down here in the denominator, they would really, if we use our exponent rules, have negative exponents on them. Okay, so those do not qualify as whole number exponents. So this, again, would not be a polynomial. And last but not least, y equals the square root of x minus 2 is not a polynomial because I could rewrite this as x minus 2 to the 1/2 power, if you remember your exponent fraction rules, and 1/2 is not a whole number. So that would not be a polynomial either. So, moving on, that's our definition for polynomials. The definition for degree is the highest power of the variable in a polynomial. Really simple concept. For example, in the polynomial y equals 4x squared minus 3x to the 7th plus 22x, this is a polynomial that has a degree of 7 because the highest value exponent here is 7. Okay, so that would be our degree. Moving on, the definition for coefficient is just any number that comes, that multiplies each term, so the number in front. So here in this example up here, 4 is a coefficient of your x squared term, negative 3 is a coefficient of your x to the 7th term, and 22 is a coefficient of your x term. So all three of those numbers, 4, negative 3, and 22 are coefficients. That's probably a review. I'm sure you've heard that word before. So that was a real quick overview of some of the definitions that are going to be important for us to know. What I would like you to do is on the bottom of some of the notes that you've been taking, and I'm sure with my speed of chatter you've had to pause the video a couple times, but what I want you to do is decide if each of the following is a polynomial or not. And so I'm going to give you 6 problems to do on the bottom of your notes, since they're pretty quick. I want you to decide if they're a polynomial or not. If it is, I want you to tell me the degree. If it's not, you can just say no and move on. And then I will start class tomorrow by going over these 6 examples to make sure that we're all on the same page about what is a polynomial and what is not. So do me a favor, answer these 6 questions on the bottom of your notes, and then we will talk about it first thing in class tomorrow.